Consider the functions f and g, where f is log base 10 of x minus 1, or regular log, plus log base 10 of x plus 3, and g is log base 10 of x plus 9. In the xy plane, where all x coordinates are the points of the intersection of the graph. Oh, okay. So I have to set f of x equal to g of x and solve. So f of x is log base 10 of x minus 1 plus log base 10 of x plus 3, the same base, equals, oh, wouldn't you know, log base 10 again of x plus 9. Whenever you're adding logs of the same base, multiply the insides. So what that's going to look like is these two guys combine to make log base 10, the little brackets there, x minus 1 times the quantity x plus 3. And you might be looking at that and saying, you know what? I bet you I can FOIL that. And if that's what you're thinking, you're right. So let me finish writing all of this out. So let's FOIL that. Let's kind of do a quick version of foiling. All right. X times x, x squared, bada bing. X times 3 is positive 3, minus 1x is positive 2x, minus 3, close the bracket, equals log base 10 of x plus 9. All right, now I still have those logs on both the left and the right. If only I can make them disappear. I can. Since they're both log base 10, I'm going to take the 10 to the of both sides. That's not proper English, but by taking 10 to the of both sides, the bases kill each other off. And all I'm left with, and let me write it out here where I have a little bit more space, is that guy equals that guy. X squared plus 2x minus 3 equals x plus 9. Now, this is a quadratic. So what I want to do is I want to move everything over to the left. So minus x, minus 9, minus 9. And that leaves me with x squared plus regular x minus 12 equals 0. Now I look at this guy and I'm thinking zero product property thoughts. Can I factor that out? Sure I can. Two numbers that multiply out to positive 1 and, that add up to positive 1 and multiply out to negative 12 are going to be positive 4 and negative 3. Set that equal to 0. Now, my two guys are going to be x equals negative 4 and x equals 3. Now, before I circle that and pat myself on the back, I have to remember that my original problem wasn't a quadratic, it was a log. So in order to make this work, you can only take the log of positive numbers. So if I were to plug 4 into these, will I get the log of a positive number? Here, I won't. So negative 4 is not allowed. If I plug 3, I'll get 2. If I plug 3, I'll get 6. And if I plug 3, I'll get 12. So that's fine. 3 is fine. But the negative 4 is not allowed because this would give me the log of negative 5, which is impossible. So the only possible ones that I would get are going to be 3 only. Tricky, tricky, tricky. And the problem is that they give you an option of negative 4 and 3. Probably the most common mistake. But be careful. It's tricky.